Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 11, Atomic Structure and Periodicity, Part 4. We're going to be talking about sp, d, and f subshells in this video, as well as the Heisenberg uncertainty principle. Pause here. So when we talk about the subshell of an atom, we're really discussing the value of L, and that is describing the shape of the orbital. And that shape is just what's called the probability distribution. It is showing where the electron is likely to be. So the shape and the energy are sort of related. In general, the more complex the shape is, the more energy that it has. But for the purposes of this class within the same level of N, we're not going to really be distinguishing between energy levels within the same value of M. Pause here. You don't need to label the axis on the picture. Right, so the first subshell is the S subshell, which is spherical. So when L is equal to 0, if L is 0, M sub L also must be 0, or L must be 0, M sub L must be 0. I only have one value of it that can have both plus 1/2 or minus 1/2. There's only two possible electrons that could be distinguished by L is equal to 0, hence the S subshell being able to have 2 electrons. Pause here. You only need one of the 3 pictures and you don't have to label axes. So when L is equal to 0, that means that M sub L is equal to -1, 0, or +1. Each one of those can have plus 1/2, minus 1/2. So there's up to 6 electrons that can be held within the P subshell. The P subshell is dumbbell shaped. Pause here. You don't need to draw the pictures. If you have that L is equal to 2, that means that M sub L would be -2, -1, 0, +1, +2. So there's 5 values. Each of those could have plus 1/2, minus 1/2. The D subshell can have up to 10 electrons. Pause here. You don't need the pictures. When L is equal to 3, that is the F subshell. So M sub L can be -3, -2, -1, 0, +1, +2, +3. So there's 7 of them. Each of them could have plus 1/2 and minus 1/2 for their spin. The F subshell can hold up to 14 electrons. Let's take a look at a little example with this. Pause here. So I'll work through it. I'm actually going to discuss these more conceptually than I'm going to discuss them in terms of quantum numbers, because that's a little bit easier for me. So if I have N is equal to 1, L is equal to 0, I already know that this is the S subshell, therefore it can have up to 2 electrons. So then I have N is equal to 2 and S is equal to plus 1/2. So I have that L could be 0 or 1. So that means for L is equal to 0, then I have M sub L is equal to 0. For L is equal to 1, I have that M sub L is equal to -1, 0, or +1. But then I see that it's MS is equal to plus 1/2. So rather than having 2 electrons for every one of these M sub L values, I only have 1. So I've got 1 electron for my L is equal to 0. I have 3 electrons from my L is equal to 1. So that brings me to a total of 4 electrons. And then for my N is equal to 3, L is equal to 0. Again, I just know this is the S subshell, therefore it is 2 electrons. We'll do a lot more practice with this because it's pretty frequent for students to be a little bit confused by it for the first time that they see this. We'll work through a number of examples during class. Pause here. Right, so we're going to talk just a little bit conceptually about something called the Heisenberg uncertainty principle. So the certainty in which you know the location of an electron is indirectly related to the certainty in which you know the momentum of the electron. If you didn't already know what momentum is the product, meaning multiplication, of the mass of an object multiplied by its velocity. So essentially what this means is if you are able to locate an electron, you are not able to measure its velocity. And vice versa. If you know the velocity of an electron, you are not able to measure its location. Thank you so much for watching and have a great night.